Hello viewers, I am Kausalya. Today we are going to solve the problem example 1.17. The problem is using block diagram reduction technique, find the closed loop transfer function of the system whose block diagram is shown in figure. So this is our given problem. This problem consists of totally 4 summing points. See 1, 2, 3 and 4. And apart from that, here this consists of 3 branch points, branch point 1, 2 and this is our branch point 3. Right. So the first step is, here I am going to move this branch point 2 before this block G2. So what is the rule for moving this branch point before the block? So this is our rule. We have to apply our rule number 4. Here the branch point is move in front of this block G. So in order to move this branch point, we have to include this block G in that point here. So this is our step in moving a branch point before the block. Similarly, here this is our branch point 2 and we are going to move this branch point 2 before this block G2, right? So the point, that is the line, this branch point we are moving, right? So here in this branch point you have to include this another block G2. That is, we are moving this branch point 2 before the block G2. So we have to include G2 in the branch which we are moving. So here this branch point comes here, right? Now the branch point 1 and 2 are in the same position. So here we have to include, since we are moving this branch point before the block G2, here we have to include another block consisting G2, right? Hope you understand with this, right? Then our next step is, the remaining things remains as such, right? So next we are going to see our step number 2. So here the step 2 is combining blocks in series and parallel. So here in this case, the blocks in series here is, here G2 and H1 are in series. So here the combining blocks in series is nothing but we have to just multiply the things which we are present. So when you multiply G2 and H1, you will be having G2 into H1, right? This is our basic rule. And the next one is combining blocks in parallel. So here in this case we are having blocks like this, that is these two blocks are in series. So first combine these two blocks. So when you combine these two blocks, you will be having G2, G3 with the summing point here. And the next one is here, we are having G4, right? So now carefully observe these two blocks. These two blocks are in parallel combination. So when blocks are in parallel, our rule is we have to just the elements, we have to add the elements. So when you add, this thing get reduced to a single block, that is G4 plus G2, G3, right? So this is our final answer. So just write this thing over here. So we will be getting G4 plus G2, G3. That's it. So this is our step number 2. Hope you all are clear with this, right? And now we are going to our step 3. So the step 3 is moving summing point 3 before the block G1. Now I am going to move this summing point before this block. So moving the summing point before the block is nothing but, here when we are going to move a summing point before a block, we have to include the reciprocal of the element to this another branch point, that is another input. So here listen carefully. Now I am going to move this summing point before this block G. So whenever a summing point is moved before the block, there is another input, right, over here. Here we have to include reciprocal of this block, that is 1 by G should be included to this input B, right? So this is our step. Here we had included the reciprocal of G here. That's it. Similarly, here I am going to move this summing point 3 before the block G1. When summing point is moved before the block, we have to include the reciprocal of the respective block. So here This is your summing point and this pointing is moved over here. That is, we are moving before the block G1. So here to the input which you are connected with summing point 3, you have to include reciprocal of this G1, right? So here I have to include 1 by G1, right? This is our step number 3, right? Hope you all are clear with this, right? Then the next step is interchanging the summing points 2 and 3. Now I am going to interchange the summing point because the reason is when these 2 points are get interchanged, then it is easy for us to solve the problem. Let me explain how. So here, that is, this 2 comes over here and 3 moves to the 2's place. So here in this case what happens when 2 comes over here, that is, the loop will become perfect, you see. When 2 comes to this place, right, here it is having G1 and feedback element is H1 into G2, that's it. This forms a complete feedback loop. So that is clearly drawn here. When the points 3 and 2 are interchanged, we are getting the block diagram like this. We are doing nothing, just we have interchanged the points. So here with this point 2 we are having H1 G2, right? So similarly here to this point the feedback element is, to this point 2 the feedback element is H1 G2. And again to the summing point I am having these 2 elements, right? 1 by G1 and H2. Similarly to the summing point 3 I am having 1 by G1 and H2. That's it, right? Simply the 2 summing points are interchanged, right? Then our next step is eliminating the feedback loop containing G1 and H1 G2. So here this forms a feedback loop, right? That is a feed forward element and there is a feedback element. Now this forms a loop, so I can reduce this loop here. So the formula here is how to reduce the loop is nothing but, that is, G1 divided by, here the type of feedback is negative, so I have to write 1 plus again the same G1, then multiplying these elements G2 into H1, right? So this is the output over here. So G1 is the feed forward element and G2 H1 is the feedback. So eliminating the feedback loop, this is our rule number 10. So G1 divided by 1, since the type of feedback is negative, 1 plus again G1 multiplied with G2 H1. This is the rule. So when we eliminate this loop G1 H1 G2, we are getting the value as G1 divided by 1 plus G1 G2 and H1, right? And the next step is, now this loop is eliminated, it is reduced. Here these 2 blocks get reduced as a single block and this G2, G3 plus G4 remains as such here. And again here listen, we are having 2 elements in series. So when elements are in series, the rule is just we have to multiply. So when you multiply here, you will be having H2 divided by G1, right? So that's all. This is our step number 5. Hope you all are clear with this, right? And now we are going to our next step, step number 6. Here step number 6 is nothing but combining blocks in series. Here these are the 2 blocks which are in series. Now I am going to combine these 2 blocks. So when you combine these 2 blocks, combining blocks in series is nothing but just we have to multiply. So when you multiply, you will be having the answer as G1 into G2, G3 plus G4 divided by 1 plus G1, G2 and H1. That is combining blocks in series. We have to multiply these 2 elements. That's it. So now just write this expression over here. So here we will be having G1 into G2, G3 plus G4 divided by 1 plus G1, G2 into H1, right? Now this is your feed forward element, right? And this is your respective feedback element. Now I am going to reduce this feedback loop. So since the elements are quite bigger, I have drawn in a separate page, and I'll explain you clearly how this block gets reduced. Right. Now this is our respective diagram. Now I am going to reduce this feedback loop. So general formula is here G, and here if I am having H, right, the type of feedback is negative, and general form of representation is G divided by 1 plus G into H. Okay, this is the basic formula for reducing. Similarly, here I am going to use the same formula here. So instead of G here, I am having this entire expression. So write this expression as such. That is G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1. Right, this is instead of G, here I am having this entire element. So divided by 1, again the type of feedback is negative, here also negative. So 1 plus, again I am having G here. So just write this G again. So G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 multiplied by H. Here in the place of H, I am having H2 by G1. So just write it as such. So here in this case, this G1 and G1 will get cancelled. So the remaining terms will be G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1. And the entire expression divided by, just when you take LCM here, this entire expression will be get multiplied with this 1. So you will be having 1 plus G1 G2 H1 plus, here I am having plus here, so plus, the remaining things will be G2 G3 plus G4 into H2. So this is our final answer of this, that is final answer while solving this feedback loop. So just write this expression over here. So the expression is nothing but G1 into, here, just multiplying, in this entire term will be divided by again 1 plus G1 G2 H1. So here this 1 plus G1 G2 H1 and 1 plus G1 G2 H1 will get cancelled, and the remaining expression will be consisting of G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2. Right. So I am writing this expression in this block. So G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2. Right. So this is our answer when we reduce this feedback loop. And again, now observe carefully. Here this is our feed forward element, and here also I am having some feedback, right? But this feedback path is empty, it doesn't consist of any element. So here in this case, we have to consider the type of feedback as unity feedback. That is, here you have to assume there is a block which consists of number 1, that is unity feedback element, right? So when we reduce this block, the expression will be again, when you use the same basic formula, eliminating a feedback loop, that is eliminating a negative feedback loop. So the formula here will be, how it will be, that is G. This entire expression represents G and this one represents H. So G, the thing is G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2. This is our expression G, right? Again 1, the type of feedback is negative, so I have to include plus. So 1 plus GH again. So instead of G I am having this one. So write as such G1 into G2 G3 plus G4, 1 plus G, right? So 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2 multiplied by 1. The place of H I am having simply 1 here. That's it. So just when you take LCM, the problem gets solved. That is G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2 full term divided by, just when you take LCM, this entire denominator part will get multiplied by 1 here. So you will be having 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2 plus G1 into G2 G3 plus G4. Again this entire expression will be divided by 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2, right? So here this denominator term and this denominator term are equal, so both the denominators will get cancelled and the remaining term is nothing but, and the remaining expression will be, here we will be having G1 G2 G3 plus G4 divided by 1 plus G1 G2 H1 plus G2 G3 plus G4 into H2 plus G1 into G2 G3 plus G4. So this is our final transfer function, because here we have reduced this feedback loop finally to a single block, and this is your respective input R and this is our respective output C. So this is our final answer. This is our closed loop transfer function of the given block diagram. Hope you all understand this problem. If you have any doubt, let me know in the comment section. Thank you.